Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 9.5, Conflicting Trial Function. So some of you who have gone and did a bit of example questions online or somewhere else would have realized that sometimes when you're doing the trial functions for the particular integral, you would have some trouble of things not completely cancelling out, and you get no particular integral. So the reason for that is mostly because your trial function have a component that is the same as your complementary function, which means that things will not end well. The way to solve it is to add 1 to your variable's power, which I will talk about with an example. So let's take a look at this version of a question, and some of you might remember from last video how the left hand side is in the question section. So I'm gonna just give it a skip, and I'm just gonna write down the CF complementary function as a e to the minus x plus be to the minus 2x, and that is the complementary function. And now we need to do a trial function. So trial function, I'm gonna write y is equal to e to the minus x. I should really use a new variable. So if my trial function is y equals to c e to the minus x, then we can do everything that we knew from the beginning. So again, trial function use these format of the right hand side of the equation, and so dy by dx is minus ce to the minus x, and d2y by dx squared is ce to the minus x. With that, all these three, we go and substitute the top. Actually, this is y. That's my bad. Substitute to the top, we get 2c plus take 3c equals to 1, and that would give us c is minus 1. Which it's kind of interesting. Actually, no, this is 3c, my bad. 3c take 3c is equals to 1, so 0 equals to 1, which simply doesn't make sense, because, well, 1c plus 2c take 3c gives you 0, which cannot give you this function, which means that this trial function is not possible, it's not correct. So we have to scratch this trial function and restart with a new one. This is why conflicting trial functions can be a problem if you didn't spot it at the first glance. Make sure if you see something to the same power of e, or the sign or cos the same x or t or whatever variable you're using, then you need to use a new method, and the trial function that is new would be y equals to x e to the minus x times an arbitrary coefficient. So in order to carry out the whole thing, we need to differentiate again. I'm gonna use the dash notation to save myself some time. For you to save your ink, make sure you use chain rule when you're differentiating. And so if you have done this enough times, then you would realize that this is actually a very, very good way of getting yourself an algebraic error. So I am not really sure if I will make an algebraic error or not, because this again is pretty complicated as you break things out. So let's see. Now I've written down all these expressions, we can add them up in this equation format, and turns out the cxe to the x terms would cancel because this is -3, this is +1, this is +1, 2, well, this is +2, this is +1, and so we're left with the ce to the -x components. So we have 3 lots of c, then take away 2 lots of c for the e to the -x, and this y doesn't contribute anything, and so we have that equals to 1, which eventually we get that c equals to 1 as well. So that's fine. So we got the trial function working, and now we can put in into the general solution the particular integral into this complementary function, such that the gs is y equals to ae to the -x plus b e to the minus 2x at 1 e to the -x as our general solution. So e to the -x, x actually, don't forget that. So your y is over here, so you add your 1 xe to the -x as your particular integral, and that would give you the general solution. This can happen again for trigonometric functions, so bear that in mind. And sometimes you would face a combination of an exponent and a trigonometric function, and again you will need to know how to deal with that one. So for tips, I would highly recommend you to check your algebra over and over again, because it's fairly easy to make a mistake there. Also remember your negative signs, because if you add something rather than subtracting, things might not end up cancel. And again, some components always cancels, such as the ones that we've dealt with just now. The one of the variable, just the c term, I think, completely cancelled. Anyway, it's one of the c terms or the cx terms. So make sure if you expected something to cancel while it didn't, it's highly likely that you made an algebraic mistake, and so you can go back and have a check. So I've set 2 questions for you today. Find the general solution of the following. And as usual, I'll give you 5 seconds to pause, and I'll show you the answer in 5, 4, 3, 2, 1. And finally, the solution is shown right here. Basically, both of them are relatively straightforward. Make sure you check your algebra, and everything should work out. So that's all for this video. I hope you've learned something. If you have any questions, do let me know in the comment section below. I'll try my best to help you. For now, thank you very much for watching, and I will see you on my next one.